Question 7, the last one here, starts quite nicely with a geometric, isn't it? So we're keeping going until we get a blue one, and the probability of getting a blue one is 1/3. So the probability that B equals 4, and we can do that logically just by thinking, well, it's going to be 3 failures and then 1 success on the last one, and that is 8/81. But the probability that B is less than or equal to 5, we'll then grab our calculator to do that one there, won't we? So into our geometric one here, we're looking for the probability that equaled, well, we'll go for the equal one first of all. Let's just check we got that one right, with the probability of 1/3 and 0.0987. Did it say exact? No, so we could have just had that there. Don't think we can get that on the, let's try it. 8 divided by 81, 0.0897, as we said. So back to my distributions menu. What was I doing? I was doing a geometric, and this time we're making it less than or equal to 5, and we'll just take the decimal off there. So 0.8683. Be interesting if they did ask that exact, wouldn't it? We'll have to think about how we'd do that without that. Now, find the expected value of B squared. Now, don't start thinking you've got to do an infinite sum here. What we can do is just remember that the variance formula is Q over P squared. So Q is 2/3 over 1 minus P squared. So 2/3 over 1/3 squared. Sorry, get my formula wrong. The variance formula is 1 minus P over P squared. I said Q there. So 2/3 over 1/3 squared, and that equals 6. The expected value formula. The expected value formula is just 1 over P. So 1 over 1/3, which is 3. And now remembering your variance formula. The variance is equal to the expected value of that squared, take away the expected value of this squared. So 6 is E of B squared, take away 3 squared. And so the expected value of B squared is 15. Now to the last part of the paper, a bit of thinking here then. If she chooses blue, her total is x squared. And x squared is the number of goes until she gets a blue. So look, this is her expected value of x squared. That's if she picks blue. She will score 15 marks. It doesn't say whether you want to get a higher or lower score, so we'll assume that we're going to try and find to get the higher score. So we now want to know what is the expected value of her e to the x one. What is the expected value of e to the x? So this would be the sum of e to the x times by the probability of getting the red one in x goes, and we'll be going from x equals 1 to infinity of all of that. Right, so this is the sum of e to the x. Now the probability of getting this in x goes is 2/3 times by 2/3 to the 1, because you're only going to get it once, times by 1/3 to the x take away 1. Let's take out the factor of 2/3, and let's take out one of the e's there. 2/3 e times by the sum of e to the x take away 1 times by 1/3 to the x take away 1 from 1 to infinity. Now, why did I take that out? Well, look, that's now just an infinite sum of e over 3 to the power of x take away 1. So it keeps going up. First term of that one there, throw in a 1 in there, is to the power of 0, so that's just 1. Each time it goes up is e over 3. Right, trying to get enough space here to do all of this. So the infinite sum series, a over 1 minus r times by 2e of all of that. Right, got 2e over, times that out, 3 minus e. Is that it? Yeah, I think that's it. Right, all I'm going to do now is figure out what that works out to give. So the fraction 2e to the 1 over 3 minus e to the 1, that gives 19.29788. Right, so if she goes for the red game, then her average score, her expected score is 19. If she goes for the blue game, her expected score is 15. So she should go with the red version if she wanted the higher expected score.